Okay guys, last time we did answer this question too and we add those vectors algebraically. We said we're going to mark the graphically representation and adding of those vectors, and we're going to do it right away. We have four forces. We have four children playing with this tug of war game on a rope, and there are two children pulling to the right and two children pulling to the left. We already answered this one, and we got that the resultant force was 400 Newton to the right. Now we are going to use the method head to tail to add graphically these two vectors. So to do this one, the first thing we're going to do is to get and scale. We have 300, 430, and we have 600 is the longest vector, and we have 350 Newton, the smallest vector. So in this case, we can use that 100 Newton is equivalent to 1 centimeter, so we can have a good representation. So for 4.2, we're going to answer right here 4.2, and the first here we're going to do is to write the scale, and we are going to say that for this one 100 Newton will represent 1 centimeter, and that is going to be long enough. Okay, so we need to consider which one is the biggest one and which one is the smallest one. So this one is the scale we're going to use, and now we have to get in centimeter what will be the length for each of them. So let's do that real fast. The first force F1 is 430 Newton, so we're going to write it one there. F1 is equal to 430 Newton. In this case it's to the left. The purpose of this one is to get the scale. So how do we do this one? We say 100 Newton is equivalent to 1 centimeters. We need to know 430 Newton, how many centimeters is going to be. You do the cross product, guys. This is the way to always do it. It's quite simple. So when you do this cross product, you will get that 100, let's use the same colors I was using before. It is 100x equal to 430 Newton. Now x is equal to 430 divided by 100, and then x is equal to 4,3 centimeters. So this is going to be what we are going to represent for the first vector, 4,3 centimeters. So when we go here, we are going to draw 4,3 centimeters to the left. Guys, this is how to determine the centimeters. I'm not going to do each of them. I'm just going to show you the answer. So if we go to F2, the second force was equal to, we'll go in here to the table, is 350 Newton. This one, when you convert to centimeters, will be, this one is to the left as well, left, and this one will be 3,5 centimeters. We're going to F3. We have F3, and F3 was 580 Newton. I'm going too fast. 580 Newton to the right, and then guys, when you convert to centimeter, is 5,8 centimeters. Okay, 5,8 centimeters. And the last force, which is F4, we have that is 600 Newton to the right, if I'm not mistaken. There we go, 600 Newton to the right, and then it is going to be 6 centimeters. So now we have the centimeters for each force as well as the direction. So we are going to be adding those vectors graphically. Now remember, the rule says you start with any of the vectors. So we're going to start with F1 to keep the order, and we're going to start at any point in the page. So F1 is 4,3. We have to make sure accurately we get 1, 2, 3, 4, and then 3 centimeters. Make sure you do it as accurate as you can. Let's erase at that and then do it as accurate as I can. There's 1, 2, 3, 4,3, more or less there, guys, but do it with your ruler accurately. This is F1 and is equal to 430 Newton. I'm not going to write the direction because you can see it with the vector. Now, what you're going to do? Right on the head of the first vector, you are going to place the tail of the second vector. In this case, the second vector is also to the left and is 3,5 centimeters. So you go to take your ruler and you measure from here the 3 centimeters, 3,5 centimeters. So let me erase out that little line there, and it's going to be, for instance, 1 centimeter up until there, 2 centimeters, 3 centimeters, and it's 3,5, so it's a little bit more there. Now remember to do it accurately with your ruler. I'm just showing you the way of doing it. This one is 350 Newton there, okay? And then from there, guys, you are going to draw the next vector. Now the next vector, in this case, change direction, and you always starting from the head of the second vector you draw. So we're starting from here, and we're going to draw the next vector down. The next vector is 3,5 centimeters, sorry, 5,8 centimeters to the right. So from here, you are going to make sure with your ruler, and you draw 1, 2, 3, 4, 5,8, it's a little bit longer, centimeters. There we go. And this one is F3, which is equal to 580 Newton. And then, guys, we almost done. We still have one more vector. Remember always to start from the head of the last vector you draw. So F4 is 6 centimeters starting from here. So it's 1, 2, 3, 4, 5, and 6. It's more or less there. If you do it accurate, you will get an accurate result. This is F4, and it's equal to 580 Newton. Now the resultant, which is the most important one, is from the tail of the first vector you draw. This one is the first vector we draw. First vector to the head of the last vector. This one is last vector. Now remember, it's last vector you draw. You can start from any vector. The results will be the same. So you're starting from here, you go all the way there, and this one is FR. Now, how do we get the magnitude of FR? Guys, we have to use the ruler. So you take the ruler and you measure. Remember, we did calculate, you're supposed to get 400. So when you measure here, it's supposed to be 4 centimeters. 4 centimeters if you done it correct. And you go back and you convert it now. You say 100 Newton is equal to 1 centimeter. So now we go all the way around. 4 centimeters, how many newtons will be, and that one will give you the answer for the magnitude of the vector. So this is x equal to 4 times 100, and that will give you, that is, then the conversion will be 400 Newton. Guys, this is the answer. It's equal to 400 Newton. Now you can write direction, but you can see it there with a vector. So it's entirely up to you. You can see here, this is the resultant vector. Guys, this is how we add vectors graphically. In this example, we have 4 vectors acting on an object. I hope you understand. Write messages if you don't, and I will make more videos if needed. Thank you for watching. Thumb up, subscribe for the channel. I'll see you next time. We're going to start with a new topic in the upcoming video. I'll see you next time. Mr. G here.